to maybe it'll help. All right, so the point is, we could list here all the inputs that might arrive at a state, right? And if, right, not inputs, but or all the prefixes, right? If I say 0, 0, I ended up here. And so you can talk about the properties that all of these inputs have. And if all the inputs that land here have the same property, then kind of the DFA knows that, right? And here, but there could be two ways of getting here, right? The input 0, 0, it does this, right? The input 1, 1, it does this, but the machine is putting them in the same state. And so we can talk, so the machine's not distinguishing them. The machine's putting them in the same state. But does the language distinguish them? And I'll say these two strings aren't distinguished. Well, one, they have the same answer, right? So that's something. So the language doesn't distinguish them that way. But more than that, for all possible futures, right? Here's a possible future, right? And then in that future, those two strings have the same answer, right? If you take alpha plus this zeta, or you take this beta plus this zeta, the two strings you get are alpha zeta and beta zeta, and see, they have the same answer, which shouldn't. Oh, here, I thought I turned it red, but it didn't turn red. All right, so they both come over here and it should turn red. All right, so now what about a different future, right? Here's a different future. And both alpha and beta, if they end up here, will come down here. And so now that's their future. And see, those are both wrong too, right? I mean, those are both dead too, right? I was trying to, not a very, yeah, anyway. So because all futures have the same answer, the DFA, the machine doesn't need to distinguish them and can put them in the same state, right? So here they are, they're in the same state. Everybody follow that? All right, so now let's try a different example. In this example, here 0, 0 and 0, 1, right? I say they need to be distinguished. One ends up here, 0, 0, 0, 1, right? They have different answers, right? So clearly they need to be distinguished by the language, right? The language says yes for one of them and no for one of them. All right, but here are two possible other strings. This one be alpha and this one be beta, right? This alpha is 0 and beta is 0, 0. So they have the same answer. So does, but this machine here is the DFA is putting them in different states. So does it need to put them in different states? And we're going to argue that the DFA does need to put them in different states. Why? Because, well, even, you say, well, they have the same answer. So why do they need to be in different states? Why are they distinguished? Well, it's because there exists the future. I can name one future, say, let's receive another 0. And if that guy receives another 0, or that guy receives another 0, right? See, they go different places. And then now this one's dead, and this one's is still a yes answer, right? So alpha followed by zeta and beta followed by zeta have different answers, and hence the DFA must distinguish them by giving them different states, right? Does that make sense? And so, in fact, on the test, what I'm going to make you do is you're going to make an NFA, and I'm going to ask you to label each state with what strings get there. And then I'm going to ask you to take one string for every state, just one string for every state. and prove that those strings each of those strings needs to go into a different state. Why? Because each pair of those, you look at each pair, and for each pair, there's a future that distinguishes them. And hence, all these strings need to go in different states. And hence, you can't have a DFA with fewer states. Are people following that? Everybody good with that? Right, this is just a little extra piece which says that if all the strings, if we partition the strings based on which ones are distinguished by the language, then that's what your states will be for your DFA. So that can help you build the DFA.
Sir, will one step have will one state will have more than one strings?
Some states might have more than one string, but your job won't be like this one has 2 strings. But when when I want you to prove that you can't use fewer states, then you just would choose one string for a conical string, one string for each
Okay.
state.
Okay, right? I got it.
And then you'll say, well, 1 1 has to go to a different place than 1 0. We don't have, we can ignore 0 0.
One right? Will represent the whole thing.
Yeah.
Yes.
All right.